Please see the link in the description to download a worksheet for this video. If you've not already done so, we suggest that you watch part 1 of contour lines before watching this video. Let's say you own a business in Florida and want to build an office on some land that is close to the coast. To reduce the risk of flood damage to your office, you decide to build on land that's at least 30 feet above sea level and has a slight slope. Ideally, you'd like to do as much searching using the internet before you start driving around. How can you find locations that meet these criteria? To answer that question, we'll learn about what a topographic map is, what contour lines are used for on a map, how steep versus shallow slopes appear using contour lines, how to find the value of a contour line, how to calculate the contour interval, how to calculate the value of a contour line, and how to calculate the elevation range inside a top contour line. We'll start by introducing what a topographic map is. This website is run by the U.S. Geological Survey. The term topo map is an abbreviation for topographic maps. Topo maps show contour lines, natural land features, and things made by people. For the purposes of this video, we'll focus on contour lines on maps and how to interpret them. Next, we'll learn what contour lines are used for on a map. Can contour lines be used to find a specific address? No. Contour lines are not designed to help us find a specific address, because all contour lines form loops. So if we follow them, we just go in a loop. But contour lines can be helpful if we want to know where a specific land feature is. For example, if we want to find the tallest peak in a mountain range, contour lines would help us. Next, let's look at how shallow versus steep land looks using contour lines. Here are contour lines at the edge of Crater Lake. Crater Lake was formed after a volcano erupted. Would you say that the steepest slope from the edge of the rim is under span A, which is facing away from the lake? Or would you say the steepest slope is under span B, which is facing towards the lake? As we learned in the prior video, contour lines are imaginary, horizontal lines that trace the edge of land at a given elevation relative to sea level. On a steep slope, the contour lines are close to each other, but on a shallow slope, the contour lines are farther apart from each other. If we could see a set of contour lines on the side of a hill, they'd look like horizontal lines that are evenly spaced. The vertical distance between two adjacent contour lines is called the contour interval, and that distance is the same for a set of contour lines. If we were to look at that land from a top view, such as how a map shows the land, then we would see the same pattern. If a slope is steep, then the contour lines are closer to each other. If the slope is shallow, then the contour lines are farther from each other. The contour lines under span B are closer to each other compared with the contour lines under span A. That suggests that the slope under span B is steeper than the slope under span A. We can confirm this by calculating the land elevation drop for each span. When we display the numbers given on the contour lines, we find that the land under span A drops 400 feet from the peak elevation at the rim to the end of span A. This drop happens over the course of a half mile, which is the distance of span A. So the slope under span A is shallow. For the land facing towards the lake, which is under span B, the elevation drop is more than 1,600 feet for the same amount of horizontal span. That means it's a much steeper slope. This is a view from the rim that's facing the lake. Next, let's look at how to find the values of contour lines. Here are contour lines around the National Mall in Washington, D.C. What's the land's elevation around the Capitol building? Sometimes we have to search around to find the values of each line, but with a little practice, we can spot them. This means the Capitol building is on land that is 60 to 80 feet above sea level. Here are contour lines on a map of New Orleans in Louisiana. What's the elevation that corresponds to this contour line? Although it can be subtle, we can see a negative sign next to the number 5. A negative sign means the contour line's elevation is below sea level. In this case, that means this street's elevation is 5 feet below the surface of the sea. Contour lines also include things made by people, like this levee, which stops water from flowing into the city. Next, we'll learn how to calculate contour intervals. What's the contour interval for this set of contour lines? In the prior video, we learned that the contour interval refers to the vertical distance between two adjacent contour lines. The contour interval is unique for a given set of contour lines. For example, if we're zoomed out, then we may only see a few lines. In this view, the contour interval is 50 feet. But when we zoom in, we'll see more contour lines, and the contour interval usually gets smaller. In this case, now the contour interval is only 10 feet. Next, we'll learn how to calculate the value of a contour line. What are the values of these contour lines? To calculate the value of contour lines that have no numbers, we first need to calculate the contour interval for that set of contour lines. To do that, we find two nearby contour lines that are adjacent to each other and do have numbers on them. In this case, we find these two lines, and when we subtract the smaller one's value from the bigger one's value, we calculate a contour interval of 10 feet. We can then go to the bottom contour line and add 10 for each line as we go up the slope. That way, we can calculate the value of the contour lines with missing numbers. Next, we'll learn how to calculate the range of values inside a top contour line on a hill. Here are some hills. What are the range of values inside these two red contour lines? Before answering this question, let's see how we could calculate the elevation range between contour lines that are not at the top of the hill, such as inside this cream-colored box. Since we know the values of the contour lines above and below the box, we can just read off the values. In this case, the elevation of this land is between 5 and 6 feet above sea level. To determine the elevation value of the land above the top contour line, we need to calculate the value of the missing contour line that's above the top contour line. We'll show the missing contour line as a pink dashed line. We can calculate the value of the missing contour line by adding the top line's value to the value of the contour interval for this set. In this case, the top line's value is 6 feet, and the contour interval's value is 1. So the value of the missing contour line is 6 plus 1, which equals 7 feet. We can then conclude that the value of the land above the top contour line is between 6 and 7 feet above sea level. We can use this same strategy for the contour lines on the map. We'll start with this one. It's easiest to solve this problem by drawing a side view of the hill. We start by drawing in the contour lines with their values. Then we draw in a dashed line for the missing contour line that is above the land. Next, we calculate the contour interval by finding the difference between two adjacent contour lines that do have numbers present. Then, we calculate the value of the missing contour line by adding the contour interval to the top contour line's value. Finally, we can summarize the range of values. In this case, the value is between 800 and 900 feet. We can confirm this by using a map tool which displays the exact elevation of land at any point we choose. All of the values are between 800 and 900 feet above sea level. The second example is a little more complicated because there are no adjacent contour lines with numbers. Instead, the contour lines that do have numbers are separated by one contour line that does not have any number. In this case, that's the gold one. We'll use a side view of the hill to write in the values that we know about and the location of the missing contour line. There are 100 feet between the top red contour line and the green one. Since the gold contour line is between the red and green one, that means the 100-foot elevation difference between the red and green contour lines represents two contour intervals. To calculate the value of one contour interval, we divide 100 by 2, which gives us a contour interval value of 50 feet. Next, we add 50 feet to the value of the top contour line, which is 850. 850 plus 50 equals 900, which is the value of the missing contour line. Now we can answer the question. The elevation of the land that is within the bounds of the top contour line is between 850 and 900 feet above sea level. We can confirm this by using this tool. All of the values are between 850 and 900 feet. This exercise teaches us that the value of contour intervals can vary even within one screen. For this set of contour lines, the contour interval is 100 feet. But for this set of contour lines, the contour interval is 50 feet. Now we're ready to answer our question about where to build an office for a new business. Our criteria will find a location along Florida's coast that is at least 30 feet above sea level and has a slight slope. Using the USGS website, we can search for areas that meet our criteria. We find many places including this nice town called Niceville, which meets these criteria. Here's a summary of this topic and some extra information. Please pause the video if you wish to read this. Thanks for your attention.